Motorcycle engineering is a multifaceted field blending mechanical engineering, electrical engineering, and design to create high-performance, aesthetically appealing vehicles. Key areas of focus include engine design, chassis construction, aerodynamics, materials science, and electronics. Engine design. Motorcycle engines, ranging from single-cylinder to multi-cylinder configurations, convert fuel into mechanical energy. Single-cylinder engines are lighter and simpler, ideal for smaller or off-road bikes, while multi-cylinder engines, common in sport bikes, offer higher power and smoother performance. Key engine parameters like displacement, bore and stroke, and compression ratio influence power output and efficiency. Modern advancements such as electronic fuel injection, EFI, systems and turbocharging enhance engine performance and reduce emissions. Chassis construction. The motorcycle chassis, made from materials like steel, aluminum, and carbon fiber, provides structural integrity and effects handling. Different frame designs, such as diamond, perimeter, and trellis frames, cater to various bike types and uses. Sport bikes may use rigid perimeter frames for better high-speed handling, while adventure bikes might favor durable steel trellis frames. Aerodynamics. Aerodynamics significantly impacts motorcycle performance, especially at high speeds. Engineers aim to reduce drag and improve stability through streamlined designs of fairings, windshields, and other components, using wind tunnel testing and computational fluid dynamics, CFD, simulations. Rider positioning also influences aerodynamics. Sport bikes feature a forward-leaning posture to minimize drag, whereas cruisers prioritize comfort with an upright position. Materials science. Advancements in materials science have led to the use of lightweight, strong materials like aluminum alloys, titanium, and carbon fiber, improving motorcycle efficiency and performance. These materials are used in frames, engine components, and wheels. High-performance tires, developed with advanced rubber compounds and tread patterns, enhance grip, durability, and handling. Electronics. Modern motorcycles incorporate advanced electronics, including anti-lock braking systems, ABS, traction control, ride-by-wire throttle, and customizable riding modes, enhancing safety and performance. Onboard diagnostics and connectivity features allow real-time monitoring and adjustments, with smartphone apps enabling riders to track performance and receive maintenance alerts. Conclusion. Motorcycle engineering is a dynamic field requiring a deep understanding of engineering principles to create powerful, efficient, safe, and enjoyable motorcycles. As technology advances, the future of motorcycle engineering promises even more exciting innovations and improvements. Thank you for listening. Please check description for much more technical books.